Hi coders, how's it going guys? So today actually we're going to be looking at the combination sum problems. This include combination sum 1 up to combination sum 5. We're going to also include the subset. So I thought this will be a good idea because these questions are pretty much the same. They differ there because of the specific conditions that have been specified in those questions. But you'll see that pretty much we changed 2 lines or 3 lines of code just to adjust for those questions. So the first one here, it's combination sum 1. So we're told that we're given the distinct integer candidate and the target. So we need to return all the unique combination of candidates where the chosen numbers sum to target. You may return combination in any order. The same number may be chosen from candidate in an unlimited number of times. So I think this is quite important also to note. 2 combinations are unique if the frequency of at least one of the chosen number is different. Also, this is quite important. So let's look at an example. It may be quite difficult to grasp this question. So if we look at the example, so we are told that we are given these candidates and we need to choose specific numbers that are going to sum to the target, right? So we can see that here they chose 2, 2, and 3, and that sum to target, and we can see that here they chose 7. So those are the only combinations that we can have, and they will all sum to target. The other ones could not sum to target. So if you probably familiar with these questions or you know problems such as how sum, best sum, you will know this technique whereby we take the target. Let's say, for example, we take this target and we try to recursively subtract all of these numbers because we just want to choose all of them and see which one actually are the right combination. So for instance, what we'll do is that we'll subtract 2, 3, 6, and 7, right? We'll do something along those lines. Then we'll get an output here. So for example, here we'll get 5, here we'll get 4, here we'll get 1, and here we'll get 0. So this shows that this is correct because we can take the 7. So we know that this 7 sums to 7. So hence we got 0. So 0 is our base case, right? So that's one way we can go about it. And similarly, we can do the same thing here. We got 5 and we need to subtract these 4 values again until we get to 0, or if we go below 0, then we know that we can't sum those numbers, right? So that's one way we can go about it. But the problem is that this approach, it is prone to duplicates. So as we saw here is that we need to return a unique combination. For instance, we have 2, 2, 3, right? So we have an output of 2, 2, 3. So we can't have something along the lines of 3, 2, 2, something like that. They're pretty much the same, although the order of these numbers is not the same, but they are the same. They all sum up to 7, but they're the same. Using this solution that we have here, it will lead to this problem. Okay, so we want to come up with a recursion in such a way that we don't face this problem, right? So how we can go about it is that we can use a backtracking technique. So let me just do this. So we can have 2, 3, 6, 7. So a backtracking technique whereby we can actually say, when we select, for instance, if we select 2, we don't want to select it again if we're going to select 3. Okay, so we always want to select unique values. So this then lower the problem to pick or not pick. So let's say we have this, we can either pick to have 2. If we selected 2, it's pick to have 2 or not pick to have it. So in this case, we can choose 2, but when we go this direction, we might not pick it. Okay, so here we can say pick and not pick. Okay, so we can choose another 2 here. It's fun because we are told that we can reuse all of these numbers as we want. So now we have 6. These 2, they sum up to 6. We can choose another 2. They sum up to what? They sum up to 8. We know that the target that was given to us was 7, right? And we need numbers that sum up to 7. So far we can see that we have 8. So this is actually greater than 7. So what does this mean? It means that we can't take all of these 2's. Okay, and this is good because now we know that actually this is going to be our also our base case. Okay, so what we can do is that we can remove we can remove this 2 that we just added, and we can return. So for instance, we had all of these 2 added. Okay, so we can remove this 2 and we're gonna be left with 6, right? Because we have picked 2 and we know that we can't pick it again because we don't want duplicates. We're gonna have to be forced to now pick 3, okay, because that is the next value on our list. So we're gonna pick 3. So what does this lead us to? This will lead us to having 9. So we still know that 9 is actually greater than the target. So we're gonna have to remove the 3 that we just added also. Okay, and we're gonna go back whereby we remove all. We're gonna also have to remove this 2. So when we get here, we can also branch and say let's pick 3. And when we pick 3, what happens is that we're gonna add it inside here. So we can see that now we have 2, 2, 3. 2, 3. This path here actually give us the correct values. So which means that we're gonna actually append this into our list. Okay, so this is actually gonna be correct. 2, 2, 3. Okay, so that is how we're gonna do it, and this is more like a backtracking problem. So that is the approach that we're gonna use. If you didn't try understand it, it's okay. I'm gonna still explain it in the code. So in terms of the term complexity, because we are making 2 decisions all the time, so it's gonna be 2 to the power of the height of the tree. So it's gonna be target. So t to the power of t or n denotes the target. So that's fine. So yeah, let's try to solve it, guys, and see how far we can get. All right, so the first thing that I'm gonna do is that, because I can see that we need to return a list, so I'm gonna try to create a list, and I'm gonna say df backtrack, and I'm gonna take in the I index, which actually I did not talk about. I'll actually expand it on here, and we're gonna have the current, which is going to store the current summation. As you can see that here, every time we do this, we just need to add a list. So you can think of that as gonna add the current list. So we're gonna ask ourselves if the total, because every time we get, if the total is equals to the target, that's when we actually want to add the current to the result. So we're gonna say results.append take the current dot copy. Okay, so here what I'm doing is that I'm just making sure that as we traverse things through the tree and we keep on adding these numbers, we want to add them to the results only if they sum up to the target. Okay, So that's the thing that we do there. Also, like I said about the edge case or the base case that I spoke about, is that we can have a total that is actually greater than the target. Now we have added more numbers that actually their sum is actually greater than the target. So we also need to return if that's the case. You will see, guys, that we're gonna have to also add an index, but I'll talk about it after I have actually explained the following code. So if none of these statements are true, then we will just want to continue to append the current element. So I'm just going to take the candidate and I'm just going to add the value, and I'm going to call this function. So you can think of here, we're doing what we did, whereby we were adding those twos, and after we add a 2, we just want to call the DFS because they said that we can pick it multiple times. So I'm just going to leave the I the way it is so that we can reuse the same number as we want, and I'm going to give it the current because we just added that value, and I'm just going to increment the total plus the with the candidate I, okay, that we just added. So that's what I'm gonna do. Because this is a backtrack, if it happens that we made a wrong decision, or maybe we added two numbers that actually surpassed the target, so what we want to do is that we want to remove them from our list. So we're gonna say current remove the last added list. So after we have removed that value, we just want to now go to the next element. So we're going to say DFS I plus 1. So we just want to say current, and we don't have to increment anything because we just removed the element, and now we're just going to go through another tree or another combination, something like that. So what we're gonna do now is that actually I've been calling this DFS instead of backtrack. So as you can see, guys, that because we keep on also incrementing the index, so we can see that the index is possible for the index to go out of bound. So which means that here on the if we should add an index as an SK. So if I is greater than or equals to the length of the candidates, so we just wanted to return also. Okay, so I'm just gonna say backtrack, actually backtrack, we can take the index, we're gonna start at 0 and we can give it a list, and we can say 0, then we just return the results. So the solution works. Just gonna submit. Cool, right? So let's look at the combination sum 2 now. So now looking at combination sum, the second question, we are told that we're given the collection of candidate number and the target. Find out the unique combination in candidates where the candidate number sum to target. So I'll say it's pretty much the same with the question that we just did now. So the only difference is that we are told that each number in candidate may only be used once in the combination. So which means that we can't actually choose a number multiple times, just like in combination 1. In combination 1, we had the privilege of choosing 2 many times as we want. So for instance, we could reuse this 2 many times so that we can actually get to the target. But in this case, in combination 2, we are not given that privilege anymore. So for instance, we can see that actually they used 1, they used this 1 also, they used the 6 to get this output. So all of them are unique, nothing was repeated. So they used 1, 2, 5, and this is 1, 2, 5. Okay, So the point that I'm raising here is that you can't just take these two and really say 2, 2, 2, 2, and you get 8. This is actually wrong. It's not correct. You're supposed to use 2 once, then find another value that is going to actually help you to sum up to target. Okay? So what's the catch then? The catch with this question is that since we are not allowed to have duplicates, so what we need to do is that if we select this element, we can't select it again, so we need to go to the next element. So for example, if we select 2 as our first value, we can select 3, but then 2 plus 3 is going to be 5, so 5 is greater than the target, so we have to go back. We backtrack, we got 2, that means we need to remove 3, then we're going to be left with only 2. Then we go to the next element, which is 2. Now we get what? We're going to get 4, which is correct. Then we still we remove this 2, but now we go to another 2. Then we get this one, which is correct, which is 4. But can you see that we just did a duplicate? We just took this 2 and this 2. So we added this 2 in our list. Then we came back, we added this 2. We added this 2 and this 2 in our list. So they are duplicates. Okay, so it's not correct. So what does this tell us? It tells us that it looks like for us to avoid duplicates, we need to sort our list so that we do not reuse the same numbers. So remember that the reuse, we don't want to reuse the same number. So I'm just gonna say same number. Okay, so if we have used 2, we don't want to select it again. So the reason we're gonna sort it, for instance, we can have 1, 2, 2, 2, 2, 3, 4, 6, is that if we select 1, right, and if we select 1, we want to sum up to 4, we can select 1 in this 2, right, but we don't want to select these other 2s because, or even if we select this 2, we don't want to select these other 2 if we select this 2. So what we need to do is that we need to always sort them. Then if we find that the next element is 2, then we're going to jump it. If we find that the next element is 2, it's going to jump it. It's going to jump it until we get to a unique number, which is 3. Okay, so that's ideally the idea. What we need to add to our code, guys. That's all. I hope you guys actually got to understand the first part, because I'm not explaining the first part since it's in the same video. So we're adding on top of the first question. So that's the only thing that we're gonna add. But you will see that during the code I will actually explain it in a more clear way, so you'll be able to understand. Okay, so let's look into it. So this is combination 2. So the first thing, like I said, is that we need to sort this. The main reason that we're sorting this is because we know that we don't want to reuse the same numbers again. So I'm just gonna say dot sort, and what we're gonna do is that we're gonna have the results that we're gonna have to return, and I'm gonna say def backtrack. Okay, and literally I'm just gonna do the same thing that we did in the previous video. So here it's gonna be here it's gonna be current, and here it's gonna be total. Okay, and I'm just gonna say if it happens that the total is equals to the target, meaning that we have found elements that actually sum up to the target, what we want to do is that we want to add those elements to the current, to the results. So I'm just gonna say current.copy. As usual, we're just gonna return. Okay, so if it happens that the total that we currently have, it's actually greater than the target, this simple means that all the values that we have added to our current, they are more greater than the target, so we need to return. Okay, we can't add them. And another thing that we need to take into consideration, because we increment our index as we continue, so we need to say if it happens that I is greater than or is equals to the length of candidates. I'm just gonna say candidates. Let's see, I think this is, or we just want to return. Okay, so I'm just gonna call this backtrack function. So literally the code is still the same, nothing has changed from the previous code. Okay, so we just got, this is where the difference is. Previously, as you saw, we were leaving I and we'll take current, something like this. But this time, because we are not allowed to take the same number multiple times, we're not allowed to repeat numbers, so we're just gonna go straight to the next index. Okay, so I'm just gonna say current plus, I'm gonna take the candidates index, and I'm just gonna say total, and here I'm just gonna do the same thing, taking the I. So this is where the tricky part comes in, right guys? So we just selected this number here, but after we have selected it, we want to make sure that the next number that follows this one, it's not necessarily a duplicate. So we just need to say check for duplicates or repeating number. So we're gonna say while I, just to make sure that we don't go out of bound, while I is actually less than the candidates, and the candidates, so we're just gonna say I plus 1 is equals to the candidates I. Then what we want to do is that we want to shift our index, so we're going to say I plus equals to 1. So what we're doing is that if we find out, because we have sorted the array, so if we found something like 1, 2, 3, and we select 2, let's say we picked 2, we found out that actually the next element is 2, we're gonna have to move to 3, so we're gonna shift our index to 3. So if it happens that we choose 2 again, then we're gonna have duplicates. So we're trying to avoid that, right? So that's why we're doing that. Then I'm just gonna call the backtrack. So I'm gonna say back, actually it's backtrack. We take the I plus 1, we take current, and we take the total. So we go to the next index, okay, after we return, because every time we don't know if the selected element it's gonna sum to the target, so it might return because of its greater. So as it return, we need to select a different index. Okay, so that's why we're doing that. So I hope you guys actually understood the first lecture, the first the previous question, because this now should be easy for us. So I'm just gonna say total equals to 0, and I'm gonna return the result. It's just the same code. The only thing that we did was to add the sort, and was just to add this while loop, and to make sure that we select a different value all the time. And yeah, those are the three things that we did that are actually different. So I'm just gonna submit, and the code works. So that's good, guys. So in terms of the time complexity, the n log n for sorting will be overwritten by the n by the 2 to the power of n of this backtracking, so the overall time complexity will be 2 to the power of n. Okay, so this will be the overall time complexity. Let's look at our combination sum rate this time around. So with combination sum, we're told that we need to find all valid combination of k numbers that sum up to n such that the following conditions are true. Only numbers from 1 to 9 are used. Each number is used at most once. Return a list of all possible valid combination. So this condition here is the same condition that we just read about from the previous question, which is combination sum 2. So we're supposed to only use number once for our combinations, but also this, we don't have to write that while loop code, because we are told that only numbers from 1 to 9 are used. So we know that there is actually going to be a distinct numbers that we need to choose from. So we are okay from this condition. So that's fine. Okay, so the big important thing that also we need to think of is the k. So the k essentially tells us that we need to select numbers up to k point, right? For example, if we are given k equals to 3, that means we need to select only 3 numbers that sum up to the target, and we need to select those 3 numbers from numbers 1 to 9. Okay, I hope I didn't confuse you guys, but that's pretty much what the question wants us to do. So it's pretty much simple, and it's similar to the questions that we have done. It's just that this time I think the main thing that they added is the k portion, whereby they give you a list of numbers 1 to 9, and you need to select only numbers up to the k that sum up to the target. See, so yeah, those are that's like the main key thing. So how we're gonna solve it? It's just an addition to the previous question that we spoke about. So one way we can do it is that we can create a list. All right, so I'm just adding on top of the previous explanations, like the 2 previous questions. So what we're doing is that we create a list of all the numbers from 1 to 9. So you can think of, we have 1 to 9. So this is our, it's more like our candidate. Yeah, you can think of this as our candidate. Okay, so after we have our candidate, we just need to select all the unique numbers from here. So we just need to make sure that we don't select 1 multiple times. So we selected once, so we're just gonna use the same code as we did. Yeah, I'll say that's it, guys. I know, like I promised you, that we're not gonna change a code a lot of times. So we're just gonna use the same code. It's just that we just need to make sure that we run the code to the k times. So with that said, I don't have to sort, because we're told that we're given the numbers from 1 to 9. So the numbers, you can think of it as they are already sorted. So you can say results equals to that, and we can say nums equals to the list. So we're creating our own array from 1 to from 1 to n. I think n plus 1. Okay, so we're gonna say the def backtrack we're gonna take I, and we're gonna take current. As usual, we take total, and we're gonna take K. So I'm gonna call it position. So the reason I'm taking K is because every time the total is actually equals to the target, we used to return and add that array to the results. But this time we want to make sure that before we add it to the array, we want to make sure that it's actually the length of current, it's actually equals to K, because we are told here, you see here, you can see that it's equals to array, and the array has 3 numbers, and also K is equals to 3. So that means we have to say length of current, it has to be equal to position. Okay, then after we have done that, now we can actually append. So if we didn't have this condition, you can imagine that we're actually going to add anything. Even if we have like 7 numbers, we're actually going to add them inside our results, and which is not true. Okay, so we're not supposed to have that. So I'm just going to say current.copy that, and we shall be able to return. And as usual, we're just going to have the same condition to say if it happens that our index, because we're going to have to increment it, if it goes out of bound, or if it happens that our total is actually greater than the n. Okay, so n is the number that we need to sum up to. So if it's greater than that, or also it could happen that nums I, right, is greater than 9. So we don't want something like that, because we're told that the numbers shall go from 1 through 9. So if it happens that we hit those edge cases, we're gonna return. Okay, so we're gonna append the nums I. So we append the current nums, then we backtrack. But as much as we backtrack, we have to select a unique number. So just gonna say current, and we take the total. We add with nums I. So you can think of this nums I as more like a candidate, similar to our thing. So the pause is not gonna change. If it happens that this path is not, maybe the total is greater than n, we're gonna pop the last element that we added. So it's backtracking, so we reverse our decision and we take a different decision. So we're gonna say backtrack I plus 1, then we take current, and we take total, and we pass the position. Okay, so I'm just gonna say backtrack equals to 0, empty array, pass 0, and we take K, which is our position. Then when we're done, we return the results. Okay, so that's pretty much the code. So I think I will have a bug. See, it's supposed to be total equals to n, because we don't have target. Sorry about that, guys. And it worked. So as you can see, guys, like I'm keep on using the same code, and I'm literally like, this time, let's see, we did not change a lot. We just made sure that we create our own candidates based on this condition, and we just made sure that every time we append to the array, we just want to make sure that if we reach K, we append to our array, and that's it. That's the only 2 cases. We did not have to add the while loop that we did add, because of we're told that we're given numbers from 1 to 9, so the numbers are sorted and they are unique, so it will be pointless. So yeah, guys, let's look at combinations 4 this time. Hey guys, so now we're looking at question number 4. So the question is combinations. So also this question is similar to the previous ones. It's just that this time we are told that we're given integer n and k, and we need to return all possible combination. All the time when you see something like this, because we need all possible combination, we might have to brute force the solution. Okay, so numbers chosen from the range of 1 to n. Okay, you may return a number in any order. So if we are given n, for instance, n like this, you can think of n as more like an array. We have 1, 2, 3, and 4. Okay, and we are told that k equals to 2. So you can think of 2 as, or k as more like a limit. So it limits us from choosing a lot of numbers. So we have to choose 2 numbers as we are building our combinations. For instance, from this array, we can pick 1 and 2. This is okay. We can pick 1 and 3. This is okay. And we can pick 1 and 4. So we can do 1 and 4. This is okay. But also they tell us that these, we can't pick them like this. So 1 and 2, 2 and 1, these are considered to be the same combination. They are duplicates essentially. And from the code that we learned, we're gonna see how we can actually avoid such use cases. Okay, so what we're gonna do now is that I'm gonna try to give you a better perspective. So we have n, which is equals to 4. We know that when we have n equals to 4, it simply means that the numbers are ranging from 1 up to 4. And we're told that k, which is going to be our limit for building our combination, is 2. So if we visualize this from a tree perspective, we can select 1, and when we select 1, essentially we can have our own results, and we can add 1 inside here. And if we're gonna select another, we can select another number. So we can't select 1, so we have to select a new number, so which means that we have to go to the next index. So we're gonna select 2. Okay, after we've selected 2, because of the base case whereby we know that we already have added 2 numbers, right? So meaning that our current array, it's actually equals to k in terms of length. So the length of this is equals to k. So we just need to return. Okay, so when we return, we have already picked 2, so we don't want to pick it anymore. Okay, so we can pick 1 and we can pick another value, so which means that we're gonna have current dot pop. So we want to pop the last element, so we're gonna pop 2, right? We're gonna remove 2, then we're gonna take the same function, backtrack function, but now we're gonna say I, meaning index plus 1. So we want to take the second index. In case here, we're just gonna say 1 take 3. Okay, so 1 is gonna take the next index, which is 3. And similarly, we're gonna return, because we're gonna hit the base case here. We're gonna have 1, then 1 will have to pick 4. Okay, and this will be 4. And similarly, we can have 2 like so, and we select all the numbers that we have, and you can see that here we selected 2. So there's no way we can select 1 again, because we already did. So we're gonna pop it. So this approach here will never have duplicates. So I'm gonna show you the code, and you're gonna understand much better. So we're just gonna have the results, okay? And I know with question 2 we sorted the results so that we don't select similar numbers, but in this case we don't have to, because we are told that our number ranges from 1 to n. So we know that we will have unique array of numbers, so we don't have to have that while loop just like we had on, I think it was the second question. So we're just going to do the same code that we've been doing all this time, which is backtrack I current, and we're just going to take k, because we have to always check if the length of our current is equals to k. Okay, so if it happens that the numbers that we've been adding to the array, they are the same size with k, we know that now we have two numbers in the array, so, or maybe whatever k is, so we just need to then append that into our results, because that means we have the correct outcomes. Okay, so we're just going to do that. So what is an edge case? So the edge case is going to be I. So if it happens that I is actually greater than or equals to the length of our current, what do we have to do? We're gonna have to actually, I think it's fine. So what we need to do is that we can also say if the length of current, it happens to be greater than or equals to k, we're just gonna return. Okay, so that's that. I wanna say, actually I forgot guys, sorry about this. Actually here it should be nums. Where is nums coming from? So nums is gonna come from the list of range starting from 1 to n plus 1. So you can think of we taking this 4 and we're creating an array. So that's what we just did. So if it happens that the I is actually greater than the length of the nums, that means that we have went outside of the array, so we can't pick any number anymore, hence we have to return. So if it also happens that the length current is greater than k, we know that actually our list is more, so we need to return. Okay, so what we need to do is that the first thing we're just going to say current dot append, take the nums and take the first element, and we're going to backtrack because we have added the first number. Then we added the first number, right? So we need to add a different number. So what we're going to have to do is that we're going to pass I plus 1. So I plus 1 essentially will take us to the second index, and we're going to add a different number. So I'm just going to pass the same array that we're building, and k won't change, will always be the same. If it happens that we go out of bound, we're going to return, or maybe let's say we able to add the correct number, or actually here it's supposed to be a return. So we're going to return from this. After we return, we want to select a new number. So what we need to do is that we need to pop the current one that we just added. Okay, then we're going to backtrack to choose a new one. So it's going to be I plus 1, then we just pass the current and we pass k the way it is. Okay, then we're just gonna call the backtrack our function, and we pass 0, empty array, and we pass k, then we just return the result. Okay, let's see, and it works. So as you can see guys, like all of this time the code has never changed. We're literally changing one thing, two things, but for the most part the code is still the same. So the fifth question is going to be subset. So this question guys, it tells us that we're given integer array nums of unique elements, return all possible subset. The solution set must not contain duplicate subset, return the solution in any order. So this question essentially is similar to the ones that we just did previously. So we just need to return all the unique subset from this array. So the previous question, we had a limit whereby we knew that we have to return subset less equals to k, right? That was what we were told. But this time, we can return as many, like they can have different length, right? They could be 2, they could be 1, 2, 3. So how are we gonna go about this? Because we need to return all possible subsets, so we're gonna have to brute force this. So let's say we're gonna make the decision of pick or not pick. So for instance, we're gonna say, can we add 1 here, right? So we wanna add 1. Then if we added 1, we don't want to add it again. So this decision, we're just not gonna add it, right? So after we've added this, we can also add another 1. So it's more like pick and not pick decision tree. So we picked 1, we can also pick another 1, which is 1, 2, okay? And here we do not pick, we have only 1. Here we also do the same, we have 1, 2, 3, okay? So we picked 3, and here we do not pick, we have 1, 2. So unlike the previous one, whereby we knew that if we added like 2 element, we're supposed to return because maybe the size was 2. But in this case, we don't have to return. We just have to like keep on adding them. So that means our base case will essentially be will be where we reach the length of the array tray. That's when we have to return. For instance, this is going to be 0, 0, 1, 2, 3. So this 3 is the length of the array. So we have to return this array. We have to append it to our result. So this is going to be appended. This is going to be appended. Similarly, this will not be a pick. This will be a pick. We did pick 2. We made a decision to pick 2. Here we're going to pick 1 and 3. Here we're going to pick 1. And you can see, looking at all of these results, they're all unique. So it's unique values. So that's how we're going to actually approach this problem. So without wasting any time, let's get into the code. So we're going to have the results, which is equals to an empty array. So as I promised, guys, the code won't change. Still gonna remain the same. It's gonna be current, and what we need to do is that we need to say if we reach the length of the array. So if I is greater than or equals to the length of nums, right? So what we want to do is that's when we actually want to results.append. So we're brute forcing this. We're going to the bottom, and we're getting those ones at the bottom, the ones that I showed you in the notebook. So we're gonna say current.append. We append the nums I, and we make the first decision. The first decision will be I plus 1. We take current after we've added that. Then we can reverse our decision. We can pop so that we can actually make a different decision. So it's going to be I plus 1. Then we can have current. We can call backtrack. We can give it 0. Empty array. We can return results. So what we have here, guys, is that essentially every time we reach the length, I is equals to the length of nums, that's the only time we're gonna add our array to the results. So it's pretty much the same with the previous question that we did. It's just that this time we don't have the limitation of adding 2. So this is the solution. Yes. So yeah, this will do it, guys. Let's look at our last question, which is subset 2, which is also similar to this. It's just that we don't have to include duplicates. So now we're gonna look at the subset 2, which is another similar question from what we did, slightly different. So this time we're told that we're given an array nums that contain duplicates. So we need to return all possible subset. Okay, so if you see this contain duplicates, this should remind you of the previous question that we came across, which is subset 2. This was the one here. And if you remember clearly, we know the techniques that we use to avoid duplicates. But the most important thing, guys, that I want you to take away from this is that being able to differentiate between these two tables and see how they differ and which one requires what. I think it's a good skill, right? So in this case, we can see that with this subset question, we have to return all possible subset. And we do not have a base case that we are defined. Like we are told that, okay, this is a base case. Maybe you have to reach a total, which is equals to target or something like that. We don't have that. So we have to go all the way down, whereby the I is going to be equals to length. Just like I explained in the previous question. So all the way down, like literally, just like we explained here, you just have to go all the way down and you get that. Okay. So with the previous questions that we've been looking at, if we go to question 2, we can see that we always had target. So we knew the condition. We had a condition that actually was going to break us somewhere. So if like we were adding to total, we knew that if total is equals to target, then we're going to have to break. But with subset, we don't have target. We don't have anything like that. We just need to go all the way down. So the only guide is the I, especially if we reach I equals to the length of nums. That's when actually we can return. Okay, so that's the key takeaway. The second key takeaway from this question is that if we have duplicates like this, we're gonna have duplicates in our results. So you can find that we have something like 1, 2, and you have something like 1, 2. So, and we don't want this. This is incorrect because our backtracking function will try to use this 2 multiple times and this 2 multiple times as we increase the index. So the best way to encounter this is we firstly sort this, so that if we use this number but we realize that the second number is the same, then we have a while loop that is actually going to go to the unique number. Let's say here it was 3. Okay, so this is literally the same equation. We're adding on top of what we just spoke about from subset 1. So here I'm just telling you like the things that we're just gonna do, like sorting and just having that while loop, and that's it. So let's go to the equation, and this is the equation. So the first thing that we're going to do, as always, is just to have the results that we're going to have to return, but we also need to take the nums and make sure that we sort the nums. The reason we sort this is because if we have, let's just take an example. If we have 1, 2, 2, 2, 3, our backtracking function is going to try to use 2 multiple times. So you'll have something like in your results 2, 2, or maybe like multiple 2, like something like 2, 2, because it will reuse this, right? And you don't want something like that. So what you want to do is that in case, because you've sorted them, if you realize that, okay, you chose 2, but the second number is also 2, then you have a while loop to say, I don't want to pick the number that is the same with the previous number. So you want to choose 3. Okay, so that's the technique essentially to avoid having these duplicates. So same code. Literally, we're not changing anything. The only thing that we're gonna change is just to make sure that we avoid these duplicates. So we're gonna say I, if it happens like I, because we're going all the way down. Unlike with the combination sum, whereby we were told that okay, if the total equals to the target, we can return. But this case, we're going all the way down. So we're just gonna say length num, and we're gonna say results dot append. We append the current to copy, and we backtrack, we return. So, and I'm just gonna say current dot append the nums of I, and we take our backtrack function, we pass in I, we choose the next element, say current, and this is where we have to write our for loop. We're gonna look at the current element, and we're gonna say it is equals to nums I plus 1. So if they're the same, so we wanna increment I plus equals to 1. But this is risky because we can increment and this can go out of bound. So to avoid that, by out of bound I mean it can go outside of the list. So to avoid that, we just need to say I plus 1 is less than the length of nums. Okay, so now we know that we're safeguarding our code, and we're just gonna current.pop the current element, because we want to use a different element that is unique. So it's going to be I plus 1, and we're going to pass in the current, and we're calling our backtrack. We initialize it with 0, and we're passing an empty current. So we're gonna return the results, and this should do the trick, and it worked. So that's the solution, guys. I hope you enjoyed working with me. This was like, I thought it would be a good idea to kind of like walk you through all of these equations that are similar and they have the same patterns, and you can learn a lot from them. I thought it was a good idea just to do them once. With that said, guys, thank you. If you've made it to this point, that means you actually enjoyed my explanation. I really appreciate it. Just leave a like and subscribe, and I really appreciate it. See you next time. Bye. Thanks.